So, welcome to the afternoon session. I'm Mark Platchon. I'm a VC here in the Valley that focuses on this area. I'm with Icebreaker Ventures. Used to be with BMW iVentures and Vantage Point and Trident. We have a very interesting speaker here from Budapest. Laszlo Kishonti is an entrepreneur, a CEO, and has a company, AImotive, that is one of the leaders now in figuring out what the architecture for vision needs to be in order to really work. So, thank you.
Thank you for the opportunity. My name is Laszlo Kishonti, as Mark said, and I'm a CEO of AImotive. AImotive is a technology and tools company for self-driving and driver assistance systems. We focus on IP, so we have software and IP for AI acceleration chips, simulation technology, and of course the core is self-driving and ADAS algorithms. So you probably don't know, but this is my second company. My first company was in the mobile space. We helped large companies like Intel, Apple, Samsung, Google, and others to build better chips. That was in a chip technology service. But before that, I was in finance. I was managing $3 billion in investments. So my take on this industry is a little bit more from the economical point of view, so investments and related stuff. But of course, as I'm managing an automotive business, I need to understand the automotive details as well. So probably you remember that 2 years or 4 years ago, everyone was super optimistic in this space. We expected by now $200 LiDARs and self-driving cars all around the world. It didn't happen, but actually what happened last year was several fatal accidents, including the Uber accident, which created quite a turmoil in the market. Most of the companies in this field have needed to reconsider the strategies. And what happened in parallel to this is that the world economy and especially the automotive industry has started to slow. The last quarter of last year was the first very serious sign that the China market started to fall by 18% year on year. And just the newest details came out for the first quarter this year, and still around 18% decline in the Japanese market, and the automotive industry as a whole is shrinking. What that means is that many of these companies who spent lavishly on the experimental research need to reconsider investments in this field, because many of the self-driving developments actually did not result any revenues in the short term, and no one knows when the revenues will come. On the other hand, you also see that probably the worst is still ahead of us. There is a trade war between China and the US, which will definitely slow down certain industries, including the automotive space. So companies like us, and of course not just the smaller companies, but the bigger companies, are starting to thinking what to do next, what will happen next. So one of the first answers of the industry was that we spent a lot of money on developing level 4 and level 5 technologies in the last 4 years. And these technologies are actually quite reasonable to increase the safety of the cars. But to reach level 4, level 5 safety with 99.9999999% safetiness is something which is not possible real time. So why don't we just recycle these algorithms and sell them as level 2 products, level 2 plus? This is how that CES many companies started to talk about these products. So instead of shooting for the moon, where everything is fully autonomous, we started to see that companies want to get shorter market revenues using the same technologies, selling us level 2+, which has two advantages. Obviously, it's cheaper to develop something which is only 99.9% safe, and also from regulatory point of view, there are no issues because, as you know, most of the countries don't have regulation for fully self-driving cars. Many countries don't even let you to sell fully self-driving cars. On the other hand, and Mark is a VC, so he probably knows better than me, what we can see is that the startup companies who received funding in the last couple of years for self-driving and the related industries have over the peak. So if you see the numbers behind me, you will see that in 2016 it was the top of the number of companies who received funding in the self-driving space. Since then, it's continuously decreasing. Obviously, the market went through the hype curve, and fewer and fewer companies have new funding rounds. That doesn't necessarily mean that the money is still decreasing, because what we have seen in the last year is that some of the fewer companies who received funding from VCs actually received very huge rounds. And this has some rationality, because these companies are either very mature in this space, or are latecomers who need much higher sums to be able to catch up. Like Aurora has had a few large funding round a few months ago. These are the later companies who needs to have very deep pockets to be able to catch up with the rest of the market. So all in all, what you can see is that the funding from internal sources in tier ones and OEMs, and the funding from investors in the startup space are decreasing this year. I hope, not hopefully, but this is what we see. And also the market is slowing, so companies need to really think about how to survive the next few years in this less friendly environment. One of the problems with self-driving in general automotive space is that each car is a very complex machine, and self-driving cars are even complex, not just the cars itself, because they need, of course, HMI to processing and sensors and algorithms and software and networking and security and many, many different components. But also the development part of the self-driving and ADAS is a very long and tedious process. And on the one hand, I'm talking about that the funding is decreasing, but if you check out the numbers, actually in the last 4 years, there have been hundreds of companies receiving smaller amount of checks. So we have now an abundance of companies in every field, which is definitely not something you would expect to be gone for the next few years. It's very similar to my former market, where my former startup was the mobile space, where in the early 2000s, everybody was thinking about 15% market share, and there were like 30 chip companies hoping for the same. And now we know the results. There are basically 5 companies owning the chip market: Apple, Samsung, MediaTek, Qualcomm, and who is the 5th one? I forget. But this is certain that there will be no 100 LiDAR companies in 5 years from now. Actually, I still haven't seen a reasonable LiDAR for the mass market cars. And so most of them will go away. They will be consolidated, go bankrupt, or just acquired. There is one more thing which many companies did not recognize, that if you check out all the automotive websites. Basically, all the major OEMs will show that they have a full self-driving R&D group which develop a full stack solution from the basics to the high-end algorithms. And I don't think that's possible at all. And many of these companies have recognized that they actually will need to be able to collaborate, because there is no way that each of these companies, and some of them are tier ones and technologies, so at least 40 companies are trying to showcase to their investors and the public that they build everything alone. So this needs to be met with the reality, and they need to admit that they need to collaborate in certain technologies which are not core to their business. So one way to do this is that OEMs and tier ones should outsource those of the technologies which are not necessarily important to keep up their businesses. And because self-driving is a very software-related technology, so the software will be key to solve these very complex problems. And even when I'm talking about self-driving, I also mean that driver assist in different levels of functionality. It's about software. And there will be special software modules where some companies will have more advantage, competitive advantage than the rest. And the large players should be able to collaborate with these companies, not just software, but the other parts as well, to accelerate their own developments and shut down those ones which have not bear fruit in the last few years. For example, we expect that these systems will get more standardized, not just because the industry wants to collaborate and consolidate, but also because there is a regulatory pressure to regulate the testing. And aviation was mentioned in the former presentations because, of course, aviation has not always have a good track record in the last few weeks because of the Boeing accidents, but overall, the commercial aviation is 100,000 times more safe than ordinary road traffic. So what we see from the OEMs is that several of them has started restructurings in the last year, and some of them are still ongoing. And what they want to build in the 2020s, early 2020s, is to come up with solutions for the market which use these new technologies like AI and the next generation chips for accelerating AI, computer vision, and so on, and spend less resources on the very high-end level 4, level 5 technologies, where the business model is fairly vague and no one knows how you can make money on the short term, especially now that the budgets are squeezed a little bit. And you should not forget that there is still a lot of ways to differentiate. So I still think that some of the companies will spend enormous amount of money on robotaxis because, for example, Uber's current capitalization would not be reasonable if you don't believe that they will once reach to the fully self-driving. Otherwise, the business model doesn't really work at the current prices. But for an ordinary car company, they should know that the average consumer doesn't really understand and don't even care who provides the algorithms for the self-driving space. They just want to see a friendly environment, both from design point of view and user experiment of point of view. So it is not essential, I think, that everyone owns every part of the technology, whatever the OEMs say. They need to be able to accelerate this process with outside technologies if they want to get to the market. soon. And I think there is only one company at the moment, Tesla, who tries to pretend that they will do everything alone. Altogether, I think Tesla is the Netscape of the automotive industries. They show a lot of interesting stuff like electrification, over-the-air updates, and now computer vision-based driving of the cars. So they are vision first, which I think I fully agree with them, because a single camera costs $15, a cheapest LiDAR costs several thousands of dollars. So currently that's a reasonable solution for the market. But on the other hand, because Tesla is financially a little bit squeezed, it might happen that it will actually not Tesla who will bear the fruits of this whole revolution which Tesla started. So Tesla at the current prices probably will be an acquisition target very soon. So if we talk about the level 4, level 5 stuff, even Waymo's limited geofenced experiments in Arizona, where every road is wide, there is no snow and nothing serious from traffic and weather side, seems to be a relatively limited success for me. Probably others will think otherwise, although we all know that Waymo has probably an unlimited budget compared to anyone else, and how to scale this business is still a question mark. So the rest of the people who gathered billions of dollars, like Cruise, to develop very similar technologies, I think is also a little bit how to say, unsafe bet at the moment, because the business model is very shaky for all of these level 4, level 5 setups, which are still not really scalable. On the collaboration side, fortunately, there are some interesting new developments. So, for example, you have talked about earlier that ISO 26262 is a classic standard for automotive safety, but it's not covering the AD and ADAS space very much. So I fully agree, but there are new contributors to this standardization process, like ASAM, and for the simulation point of view, which I think is very crucial for the market, there is new formats like Open Scenario and Open Drive. Governments will come and regulation will come. So we were already afraid before the Uber accident what will happen. And it's a very strange sentence. What I will say is that it's very fortunate that it was not a group of kindergarten kids who were hit by the car, because otherwise there would be no market, and every government would regulate this space much more aggressively. And I expect that the Wild West, what is in Arizona at the moment, will not be there for a long time, because accidents will happen, and governments will start to develop their own recommendations first, and then very strict regulations, similar to what the aviation industry has, because if people die on the road for unnecessarily risky experiments, then politicians will step in. And I think it's better to have these regulations started from the market instead of from government pressure. And I know it's not the same thing, but Euro NCAP and NHTSA in the US are turning up the complexity of the standard ADAS tests. So some of them are actually not even possible to solve without using the mentioned technologies which are coming from the research for self-driving cars, like different maneuvers, evasive maneuvers to not to have an accident. Simulation. So going back to aviation industry, everyone knows that in the last 40 years, all the pilots and the aircraft has been trained and tested on simulators. And why simulator is important in this self-driving space is the same why it's important in the aviation space. It's cheaper, it's safer, it's repeatable, and saves time. So for example, winter, you don't need to wait for summer weather, and summer, you don't need to wait for winter weather. And because it's repeatable, this is very important, you can base your continuous integration development process on simulated technologies. I agree that the simulation does not totally enough, so you still need to have a real-world road test, but at least it provides a safety net and predictability in the development environment. By the way, this development pipeline is our own development pipeline, so we use a simulator every day. A single engineer makes a single code change, no matter how small it is, it triggers thousands of simulated scenarios, so he will instantly know that if he made the software stack better or worse. And actually we spend 10 times more amounts of computing power on simulation than training AI, which was the buzzword in the last 2 years. One more thing, this is also a very funny example, HD maps. I think mapping is very important, but if you look around the market, what you will see is there are competing solutions, but none of them are really scalable. Even the large companies like Here and TomTom doesn't have a coverage fully in the world, and HD maps are usually outdated from downloaded the day you download them. So this is very interesting that there is no HD map standard at the moment, and there are at least 10 different companies working on a very limited solution, although mapping was a 4,000-year-old invention to share information. And this is so strange that if you want to buy HD maps, most of the cases what you will find that you need to build them for your own because there is no standardization and there is no coverage. So this is a very good example how immature the market is at the moment, and I think this one needs to be solved. So I'm sure that Elon Musk, for example, when he said that he doesn't need HD maps, is not because he couldn't improve the safety of the cars with HD maps. It's sure 2 of the accidents wouldn't happen with HD maps, but because there is no accessible supply of HD maps coverage globally. So just to conclude my presentation, so we expect a lot of consolidation in the next 3 or 4 years. Most of the companies will disappear in this market, and I don't think there is any company in this space who can safely say that they can solve all the problems alone. So what we expect beside the consolidation, that there will be standardization, both from modularizing the technology stack and both from a regulatory point of view, especially for the validation and the testing. And modularizing the software is one thing, but the testing will be done mostly on simulator, very similarly to the aviation industry. Thank you very much.
Thank you. Excellent. Very interesting. We have a couple microphones here for people to have questions. Please come on down. And in the meantime, I'll kick it off with the first question. You're arguing that there's lots of little companies developing stuff. They should all switch to doing modular pieces so that they can be experts in their piece and somebody puts it together. Who's in the position to put it together?
That's a good point. So what we have seen is that the automotive industry is still very conservative. The product cycles actually did not accelerate that much. So that's why I mentioned that the Tesla's over-the-air update approach is something kind of like revolutionary. At the moment, the case is still that although OEMs want to have more control over the software stack, but because the hardware piece and the integration is still mostly done by the tier ones, the old balance has not been broken yet.
Anybody want to come down with a question? So if the OEMs don't have the skill set to do it, the tier ones want to keep it proprietary for just their customers. Who does that? How does this shake out?
So there is one thing we have recognized is that, for example, in S-Class Mercedes, there are 150 chips. There are chips.
150 ECUs.
ECUs, yes.
It's ridiculous.
Yeah, so there is even a separate ECU for the air conditioning. This is, I think this shows, especially that the Airbus A380, which is the largest passenger airplane in the world, it has 48. And your computer would look like stupid if you would need to have a separate chip for word processing, another one for a spreadsheet, and another one for email. But this is how the market looks like. And as the ADAS features get more complex and sophisticated, what most of the people will recognize that it is much easier to integrate everything into a central ADAS or AD computer. That's what obviously NVIDIA is preaching. Now Tesla has its own computer. I think in that case, again, Tesla shows something, a purpose-built computer for AD. That's what we will see in the next 5 years in most of the OEMs' case.
Yeah. So there's different philosophies about simulation. You've argued, others have argued, that simulation is the way to go. It's the way airplanes go. And that's the way we get baseline safety. But in my naive view, the simulators wouldn't have created any of the situations that have caused the crashes and the deaths so far. Those corner cases, those weird things, one, they don't happen in the sky, and they're ridiculously hard to predict. Chris Anderson, the editor of Wired, has promoted a completely different approach that says we should be testing vehicles where it's fine to crash. They should be cheap, they should be small, they should be light, and they shouldn't have a person in them. But remote racing or robo-racing would allow everybody to learn really fast, do very little damage, and make progress super fast, and let it be a competition so everybody can test, change their software, go out and race some more. And instead of creating a whole fleet of cars that drive like grandma and cruise cars that get stuck at every intersection, you end up with cars that are nimble and fast and avoid problems and can go find a million corner cases by racing.
I don't agree with this because it's like I would say that if you can drive in a Mario Kart, then you will be able to drive everywhere. So I don't agree. But what is very annoying to me is that the latest Tesla accident is very, very similar to the last year's one. So the same thing, a big object beheaded a driver. Sorry for the description. So it means to me that that specific, already well-known situation has been not reproduced in a simulator, even if I know that the old car was using a Mobileye technology and the new one probably used NVIDIA's own, NVIDIA plus Tesla's own stack. So what will happen is that regulators will require companies, car companies, to have black boxes, and all the data will be uploaded to public data sets. And from these public data sets, the regulators will sample the most important situations, and that will be the base of a regulatory test. That's how.
Okay.
Because every year hundreds of thousands of accidents happen, so there is enough sample without doing races.
Everybody, let me thank Laszlo.
Thank you.